Again, just from this, looking at the denominators, you could right here determine what values of x will not work in the equation. Do you right now? I don't know. Let's ignore that for now, okay? We'll come back to it. So what I got here, I'm going to look I'm not even focused on the numerators here right now. I'm just looking at the denominators because if I can get the denominators to match, I can ignore all the denominators. So my 3x plus 3, I noticed that this can factor out a 3. So let's do that. Okay, so the denominator there is now 3 times x plus 1, right? 3 divided by 3 is 1, 1x. And then 3 divided by 3 is 1 because we factored out the 3. I didn't really change anything else on that, so I still have the rest of it like this. It's a little off, but my numerator was 6. Okay, now I still am not concerned about my numerators. What I am concerned about is just the denominators matching. And having factored that out, the 3 here, I can see I've got an x plus 1 and an x plus 1. That means that part of those denominators, at least those parts match, right? So right off the bat, I know I'm going to have to be multiplying by stuff, so I'm going to put this in parentheses, just so I don't forget. But let's look at each of the denominators, see what's missing, all right? So this one has an x plus 1. It's missing a 2, and from this denominator, it's missing a 3. So you could say you're going to multiply by 2 and 3 there. Really, you could just multiply by 6. You know what, I'm going to keep that there, though, okay? So, but if you do it to the denominator, you got to do it to the numerator as well. And now this fraction becomes 3 times 3 is 9 times 2 is 18. 18 over, I'm going to show it as 6 times x plus 1. Okay. All right, so that's that denominator. But let's move on to this next one from the minus 1/2 right there. So I have the 2, but it's missing the multiply by 3. So let's put that in there. So this one, 3 times 2, 3 times 1. But then it's also missing the x plus 1. So I got to multiply that by x plus 1. Both denominator and numerator, by the way. So now my numerator denominator, it's 3 times 1, that's 3. I'm going to keep the x plus 1 separated for now. And then the denominator, 3 times 2 is 6, and that's multiplied by x plus 1. Okay, so right here, just from what we've done, and yeah, there's subtraction between these, but we have common denominators right here. We just need this last one to be common. So that's where, and it's equal. I'm going to multiply that 3 by 2, so the 6 by 2 as well. So now it is 12 over, again, we've made that 2 times 3, that's 6, and then we have the x plus 1. So I've kind of purposely put that in red so that we can see that these denominators all match. But because they all match, now I can rewrite this just with the numerator. So then now it's 18 minus 3 times x plus 1. And this is going to equal that 12. All right, so this becomes an equation to solve. And I see that I have distribution from the parentheses there, right? So I got to distribute my negative 3. Negative 3 times 1x would be negative 3x's. And negative 3 times positive 1 would be negative 3. Okay, now the rest of it just drops. We got 18 minus 3x minus 3. This equals 12. We did distribution. Now we're looking for combining like terms. I've got 18 minus 3, which is positive 15. So now it's negative 3x plus 15 equals 12. Because I didn't see any other like terms to combine. And now that we've gotten to this point, I'm looking for principles of equality to isolate my x's, right? So I'm going to subtract 15 from both sides. And that allows me to drop my negative 3x's in green. Equals, because the 15 zeroed out, 12 minus 15 is negative 3. I think some of you guys know how this ends, but finally, we'll divide both sides by negative 3. And I get phantom 1x equals 1. Okay, now if I've done this correct, I should be able to come back up here to the top and replace, there's only 2 x's there. I can replace those x's with 1 and see if I get a true statement, okay? So I'm going to take that x, it's a 1, and this other x, I replace it with 1. Is this going to be true? So that's my question mark over the equal sign. Well, my calculator will tell me. So I do again, you can do this in your head, but it'd be 3 over 1 plus 1 minus 1/2. And I got 1 on the left. So the left side of the equal sign gives me 1. What about the right side? Well, it's 6 over 3 times 1 plus 3. Enter, I get 1 on the right side as well. That's true. 1 actually does equal 1. And again, now I know that this actually is a solution to the original equation.
Isn't it